If you're a cat, it's time to sleep on your head. If you are a human, it's time for section 1.6, putting it all together. So let's start with this example. We got 3 examples in this video, just combining a lot of fun stuff. Fun, capital F. Example 7. Working as an insurance salesperson, Ilya earns a base salary and a commission on each new policy. So again, just think about the phrasing that we've talked about. A base salary, okay, that's something that's fixed, happening all the time. And a commission on each new policy, oh, that's variable payment. Oh, okay, fixed and variable. Oh, this is looking like it's going to be something like a line maybe. So Ilya's weekly income, let's call that I, depends on the number of new policies N that he sells during the week. Last week, he sold 3 new policies and earned $760 for that week. And the week before, he did 5 policies and earned $920. There's a lot of directions that you can go to solve this problem of finding an equation for that function I of N. What is the income as a function of the number of new policies that he sells? Well, I think the most straightforward for this class is just doing things the way we have been doing things. But again, it's your choice. Let's write things as an ordered pair. Okay, can write things, if the new policies, right, this is our input, new policies, this is our output, income. If the new policy was 3, the income was 760. If the new policy was 5, the income was 920. So if we think it's going to be a line, it's kind of like we have 2 points, right? This is an input and an output. We could write this as the ordered pair 3, 760. You could write this as 5, 920. Or if you wanted to, you could call this N1 and this N2. This I1 and this I2. And we can use that slope formula that we've been talking about. And then we'll have to find the B value. What's the starting value? We'll have to find that initial value, not fixed costs in this sense, but fixed income. We got the fixed part and the variable part. That's true for any line. So let's look through it. All right, the slope is going to be the change in outputs, second income minus the first income, I is the output, over the change in inputs. How many policies on the second time? How many policies in the first time? Doesn't matter which one's which, as long as you're consistent. So I2 is 920, I1 is 760, N2 is 5, N1 is 3. Did not give myself very much room here. 920 minus 760 is 160, I believe. Bottom is 2. Okay, that's 80. What does this 80 mean? First off, we need the units. Any rate of change comes along with units, and the units of a rate of change are the units in the output divided by the units of the input. What are the units for dollars? The weekly income. Sorry, what are the units for income? And the answer is dollars. You could say dollars, you could say dollars per week. I would take either. Let's just keep things simple and say dollars per units of input. What are the units for these N's? That's the number of policies sold. $80 per policy. And as soon as we attach units to this slope, the meaning of the slope becomes much easier to see. $80 per policy. Oh, he gets a commission of $80 per policy that he sells. Great. That's the slope. And that helps us with the interpretation. I think I'm jumping ahead of myself. Jumping ahead of myself. Let's finish letter A. Okay. I just get excited. I can't stop myself, you know? So we need our B value now. B is a starting value. Well, how much does he get? And you don't have to do this mathematically, right? If you just get here and you say, well, $80 per policy, and he did 3, well, that means he must have gotten $240 from those policies. We can find out that his starting was $520 as his fixed pay. But if we want to be consistent, you can write it with math. But if you just can do that logic and write that down, that's great. Okay, so first step was finding the slope. Second step was finding the b value using one of these points. Doesn't matter which point. So we know the income based on the number of policies is b, which we don't know, plus the slope, which we do know, times our variable. Right, it's just like we did in example 6. Well, then let's choose one of these. It doesn't matter which ordered pair we choose. You could choose this one. You could choose this one. We'll give you the same answer. I like smaller numbers, so I'm going to choose this point. That says that when the input's 3, the income is 760. The output's 760. When the input is 3. Solve for b. 760 is b plus 240. Subtract 240 from each side. And you're going to get that b is 520. Again, if we want to include units, it'll be $520. And we'll end with saying, okay, that means I of n is b, right? We just said that up here. It's b plus 80n. And now we know what b is, so we're basically done. 520 plus 80 per policy sold. That is Ilya's income, linear. And that's the simplest form of income for a lot of commission-based jobs. All right, and this is per week. So I guess it depends on how many things he's selling. Interpret the components meanings for this equation. Well, we kind of already did, but let's do it more precisely. I'm going to be a little lazy. I'm going to type it. Okay. So the slope, right, is $80 per policy. And that means he gets a commission of $80 per policy sold. Great. 520 is the y-intercept, or the starting value. Starting value, it's the guaranteed income he receives each month. All right. Here you go. Make the font bigger. What are the independent and dependent variables? I don't think we talked about this very much. Independent is always going to be our input variables. And dependent is always going to be our output variables. So in this case, our input was our independent variable. That was the number of policies sold. The dependent variable was our output, which was I. Again, N, the number of policies sold. This is going to be I, the income for that week. Here we go. What's a reasonable domain and range? Oh, this is going back 2 sections. Domain is all the inputs that make sense here, and range is all the outputs that make sense here. What kind of inputs make sense here? What kind of N values make sense here? What kind of number of policies that it makes sense? Well, the domain, it could sell 0 in a week, or 1, or 2, or I don't know. I don't know what a reasonable maximum was. So let's just guess 100. Notice I'm not using interval notation. I probably wouldn't dock points if you used interval notation. But it's not everything between 0 and 100. It's only the integers between 0 and 100. Right? He can't sell 2.5 insurance policies. And again, I'm not grading based on these brackets, but technically they should be there. What range numbers make sense? Range is the reasonable outputs, reasonable weekly income levels. Well, he's definitely going to make at minimum 520. What's the maximum? Well, if he gets, right, if he's making 80 per policy and I'm saying 100 is going to be the maximum number of policies, That's going to be 80 of that. Going to be 8,000. Okay. So the maximum income, right? We're counting by 80. We're really being precise. Counting by 80 all the way over to 8,520. That's a nice weekly income. I'll take that. Okay, so this is way too big. This is way too big, but it doesn't matter. There's no way he's selling 100 insurance policies. And again, if you answered in interval notation here, I'd probably give it to you. Even though it's technically not right, but it gets the point across. So pause the video right now and try to do this next problem. The balance in your college payment account, C, balance C, okay, is a function of the number of quarters, Q, you attend. Not dollar quarters, quarter of a dollar, but number of quarters you attend at, let's say, South Puget Sound Community College. Interpret the function in words. And pretend that this is a Q. So how many quarters of, let's do one thing at a time. Interpret that function in words. So the balance is C. So the balance starts in our account, starts at 20 grand. That's the B value, right? And negative 4,000 is our slope. So it decreases by $4,000 per quarter. Or you could say that it costs $4,000 to go to this college for a quarter. That would probably be a little bit better. Or you could say it costs $4,000 for each quarter. And maybe this includes room and board, I don't know. Well, if it includes room and board, then your tuition, room, or board is cheap, which would be great. Anyway, how many quarters of college can you pay for? It depends on what kind of college. How many quarters of college can you pay for until this account's empty? Ooh, this is our first answer. When is this account empty? It's empty when the balance, which is C, equals 0. So another way of phrasing this is solve C of Q equals 0. We want to know when this balance is 0. When is the output 0? So if you think all the way back to section 1.1 where we started, right? This is why we introduced that language, because that's really what we're trying to find here. So when is the output equal to 0? Output is the left-hand side here. And that's going to be when 20,000 minus 4,000 Q is equal to 0. We can add 4,000 Q to both sides. And now we have 4,000 Q equals 20,000. Divide both sides by 4,000, and you'll find that Q is... That's not good. You can go to school for 5 quarters, and then you got no money. Maybe this is an appropriate, accurate answer. Good luck. So hold on, that's not our answer. Q equals 5 is not our answer. Right? If someone asks you, how many quarters of college can you pay for until this account's empty? And you say Q equals 5, that's kind of weird. Can go to school. You could just answer 5 quarters, actually. You don't need the full sentence. 5 quarters is a good answer. Can go to school for 5 quarters. All right. Maybe it hits a little too close to home. Let's do one more example. Look at this table below. We haven't done much with tables in this section, but I did mention you could. So let's look at this table below. Write a linear equation that represents the table values. Remember, a linear equation is going to be P of W. That's our function. Our output is P. P is a function of W, so we write it as P of W is equal to some starting value plus some slope times our variable. Well, what's our starting value? Starting value is when the input is 0, or the y-intercept. That's going to be 1,000. And then m is just our slope. Be very careful. I'm going to write down the wrong answer. Think about why it's wrong. I could just say, oh, look, we're adding 80 and then adding another 80 and then adding another 80. But the problem is we're adding an 80 every 2 weeks. So if we're adding 80 every 2 weeks, that means we must be adding 40 every week if the rate of change is constant. And you could use the same formula to find m. I don't think you necessarily need to here, right? If it's 80 every 2 weeks, okay, it's 40 every week. But this formula can be very helpful in getting you there. So it's an option. So I believe that's the whole question. You survived. Probably. I guess there's a very low chance that I'm not going to finish that sentence. You survived. Congratulations. Good luck with the homework and let me know if you have questions. Bye-bye. Don't get me fired.